I'm going to just graph a few ellipses using our sort of regular approach here. So one thing, when I look at this equation, the way I know for sure this is an ellipse is that it's a plus there. Hyperbolas have a minus. The other thing is we do have parabolas. Parabolas only have one squared variable. Ellipses and hyperbolas have two squared variables. So do circles. For a circle is really just an ellipse where these denominators would be equal. So the major and the minor axis are actually the same. What we do here, we look at this. That's a squared then is 25. A squared is always bigger. So a would be the plus or minus square root of 25. So that would say that a is plus or minus 5. And what's important then is to realize that 25 came from the x term. So this is how far we move in the x direction. The other thing here, b squared then is 16. So b would be plus or minus the square root of 16, which would be plus or minus 4. And that's from the y, so I move in the y direction. Now, in these cases, all of these are just going to have x squared and y squared by themselves. That means the center of the ellipse is going to be at 0, 0 at the origin. All the problems we do in this class, we're going to be centered at the origin. So I start at 0, 0. I move 5 to the right and 5 to the left. And then I move 4 up and 4 down. And those 4 points will determine my ellipse. In the mini lecture, I found some other points. We really don't need to do that. The other thing, it's not essential for an ellipse, but I sort of find it helpful when I'm graphing. We need to do this for hyperbolas, but I just go ahead then and I draw in this rectangle. Because what that does is I know then that my ellipse has to fit inside this rectangle. So that sort of just gives me something to aim for. I know I'm going to have to come here and stay inside the rectangle. That's going to be my ellipse. I've had better ellipses, but that's what we would have here. For this problem, down here, my b squared is 16. Now, honestly, for what we're doing in this class, if you still called it a, you'd get the right graph. But in theory, it's really b because it's smaller. And then so we'd have a squared is 49. So that would be plus or minus square root of 49, which would be plus or minus 7. And again, the center here is starting at 0, 0. But where did this 16 come from? That was from the x. So I move that far in the x direction, and the 7 is what I move in the y direction. So I move 4 in the x direction, and 7 in the y direction. So up 7 and down 7. And then I could draw in my rectangle if I want. Right. So, and then I know my ellipse has to fit inside that rectangle. So it's going to come up, down here, and curve around, and there would be the ellipse. So ellipses we graph that way. Let's graph a couple hyperbolas. They're not really too much harder. For a hyperbola, again, the way I know this is a hyperbola is because it's a minus here. For a hyperbola, a is always first. So I would have here a squared is 9 and b squared is 16. So a would be plus or minus the square root of 9. That would be plus or minus 3. And that came from the 9, which is with x. So that's how far we're going to move in the x direction. B, on the other hand, comes from the y in this case. So that's how far I'm going to move in the y direction. And just like for an ellipse, since it's just x squared and y squared, my center is just at the point 0, 0. So I move 3 in the x direction, up and left and right. I move 4 in the y direction, up and down. That tells me how to make my rectangle. Now, it was optional for an ellipse. It's not optional for a hyperbola. Because for a hyperbola, I need to draw in the asymptotes, which are the diagonals of this rectangle. So I just go along and I go from the corner to the center to the other opposite corner, and it keeps going. Same thing here. Now, since x is first, that means it's horizontal. So when I'm graphing this, it has to, the hyperbola always starts on the rectangle, but the question is, where does it start, on the sides or on the top and bottom? Since this is horizontal, it starts on the sides. So it's going to start here. This is called the vertex. It curves away from the box, but then towards this asymptote up here. Away from the box, towards the asymptote, and it does that on both sides. Why is it doing that? All right. This one below, the difference, of course, now my first is 16. My second is 9. So A is plus or minus the square root of 16, which would be plus or minus 4. But now that 16 came from the y, so that's how far I'm moving in the y direction. And this 3 then is how far I move in the x direction. And again, I start at the center, 0, 0. So we move 4 in the y direction and 3 in the x direction. What's sort of interesting here, I'm ending up with the same rectangle that we had up above. Right? This is exactly the same rectangle. I draw the corners, and I draw the diagonals through the corners in the center. Sort of sloppy there. The difference though now, y is first. So if y is first, that tells me that the hyperbola is vertical. So I'm not going to start on the sides. I'm going to start like up here at the top. It's going to go away from the box and towards the asymptote. So as long as I have these hyperbolas and ellipses just centered at the origin like this, it's relatively straightforward to graph them.